All right. Thank you for joining our talk. We know we're the last session before the lunch, but I promise you it will be interesting. We're going to tell you about our experiences with running container workloads on secure Kubernetes clusters, and we will also tell you about how our cloud platform evolved over time. Before we do that, I would like to quickly introduce ourselves. I'm doing this presentation together with my colleague William Artero, platform engineer at the Public Cloud Platform Department. And myself, I'm Laura Rehorst. I'm the product owner of the container platform teams. We both work at ABN AMRO Bank. I guess most of you know that we are a bank in the Netherlands, exist for over more than 300 years. We are a pretty large enterprise. We have plus 20,000 employees. A large part of that is also active in IT. And they facilitate the business by building applications, running systems for them. We have around 1,400 applications that 600 DevOps teams are responsible for to build them, to maintain them, but also in collaboration, of course, with our vendors. We are active in the financial sector. So that means that we have a really interesting case because we have sensitive data, we have critical processes, and we need to balance there because we need to innovate, be sustainable, we need to be compliant and secure. So that makes it really interesting for us. And of course, we have to deal with regulators like DNB, the Nederlandse Bank, and the Authority of Financial Markets. We have a target cloud strategy. In our case, it's Azure. We have a special program called Apollo. They prepare the teams to become DevOps, get the DevOps mindset, but also prepare their applications technically so they can migrate. So it's really to accelerate that transformation. And when these teams go to cloud, they can choose if they want to use containers. And we see in the market, of course, that the popularity of containers is increasing. Well, some reasons for that is because they're lightweight. If you compare them to VMs, they are requiring less system resources because they don't have this whole operating system layer as part of it. And they're portable. So that's ideal situation, of course, for if you want to migrate and also for future, maybe for exit strategies. And these containers, they're running on a container platform at the bank. We use Azure Kubernetes Service as a core for that. And we have 35 AKS production clusters at the moment. And for that, we have a platform team called Stratus. This team has been created because we needed to create a solid container platform. We do that by delivering reusable components. So you can think of pipelines that we give to the teams, but also Helm charts. And with these reusable components, they can create a cluster that is secure and compliant, but it also has some facilities out of the box that they can use. And we use Azure policies to enforce policies on clusters and the environment. But we also, for example, use Prisma Cloud Compute as a tool for container security scanning. And we do it both at build time in the pipelines, but also during runtime with PCC defenders. And this team is also responsible for the daily support. We do that in the Teams channel. We just answer the questions there. Everybody can read that. And we do consultancy for complex use cases. Well, once we delivered that platform, we saw that the popularity of containers was increasing as well in the bank. So then we thought it was time for another team called the Container Governance Team. And the reason why we created this team is because the amount of images was growing inside the registry, and we needed to make sure that the teams understood well on how to build container images in a secure way, how to maintain them, but also where to store them and how. So together with other departments, we created container standards and best practices. Service ownership and discovery, also important. So you have a lot of container images and you want to know who is the owner of one. Then you really need to improve the taggings and annotations that you give in the pipeline. So we did that, and that now gives us a bit more visibility and control over what is now actually in these registries. And we need to facilitate the DevOps team. So if you want to work with containers, you will need tools. So we make sure that the latest versions of, for example, Docker Desktop are available on the laptops. Another thing we observed is that as part of the container images of teams, the operating system layer is often used by multiple teams. So what we thought, okay, what if a CVE enters in this, appears in this layer? Then all these teams will need to fix it themselves. So let's take the ownership of container-based OS image, as we call it, make sure that we harden it, that we are the real owners of that, publish it in the central registry, then all the other DevOps teams can fetch that base OS layer, incorporate it in their container image, and then when something happens, it's clear where to go, because there's one team owning it, and we can then take the action instead of every team needing to fix it themselves. I think I broke it. No, it's okay. Yeah, and as you can imagine, it's very complex because we have a lot of different departments responsible for all kind of different tools for the pipelines, but also security departments like CISO. And you really need to coordinate that whole governance so to make sure that everybody is aligned and has the same plan, because otherwise you cannot create this ecosystem for containers. Well, we have a pretty large container community. And like I already said, that is part of the Teams channel that we have. So there we do the support. People can also react. So if someone is coming with a question, sometimes other DevOps teams also answer onto those questions. So it's really cool to see facilitating inner sourcing as well there. We retrieve feedback by posting questionnaires, also to find out if there are, besides Kubernetes, other services that teams would like to see on the Azure cloud for running containers. And we do knowledge sharings. That's really important because over the time, our team has gathered so much knowledge and experience that we need to share that with the other DevOps teams. And we also want to inspire them, of course. And then I would like to tell you a little bit about the history of the bank. Don't worry, we won't go back that far. I'm going to tell you a little bit about the evolvement of the cloud platform. So we started in 2017 with a cloud platform based upon secure products. And well, for us, that means you have an Azure service, we disable and enable some features to make it more secure. And in some cases, we put a secure layer on top of the service, and then we give it to the DevOps teams to use. And in this first model, the DevOps teams are only responsible for developing their application, the development of the infrastructure, but even the deployment of the workloads was done by the platform team. Well, you can imagine that this platform team became a bottleneck because for every small change, this DevOps teams needed to reach out to the team. So we shifted to a model which is a bit more in line with the DevOps mentality, and that is giving the DevOps teams more responsibility. So they could now also deploy their own infrastructure for their workloads. But still, there was a dependency because the platform teams were still developing the infrastructure, and we had the secure products. And if they needed to be changed, then that platform team needed to do it. So that brings us to today, where we said goodbye to the secure products, and we went to the secure context, which is based upon the Microsoft Enterprise Skill Landing Zone. And there, DevOps teams get even more responsibility. They now deploy their own infrastructure. They also develop it, and they can do that with infrastructure as code tools like Bicep, but also with Terraform. They co-create with us on new Azure services we want to enable within the secure context. The platform team is responsible for creating the Azure policies so that you have the secure context, like the guardrails, and within these guardrails, the DevOps teams have the freedom to work with their applications. Also, the platform team gives reference templates so that other teams can get inspired by that and use that in the preparation of their own templates. And this part brings us actually as an introduction towards William's part, where he's going to deep dive into the differences between the secure products part and the secure context part.
Thank you, Laura. Well, hello everyone. My name is William. I'm part of the platform team at ABN AMRO, specifically a status team. Recently joined the container governance team. I'm a software engineer by heart. Started 11, 12 years ago as a C++ developer. Worked on enterprise desktop applications for Windows using MFC before WPF was a thing, for those that know that. Worked also with Com+ using Visual Basic, so I'm not proud of that. And later on, after a few years, I shifted my career more towards business analysis and automation because I got into contact with the DevOps practices, and I felt my own struggle in the past, and then I found that that was the best way, the best course of action for me to help myself and also my teams, and then I focused more on that. And lately, I've been part of infrastructure teams, SRE teams, and platform teams to help business to scale their services offerings without scaling the operations together, because that's not what businesses usually want. So before I deep dive into the 2 implementations we have, I'd like to fire some questions to get to know the audience. How many of you are familiar with Kubernetes? All right, pretty much most of the room, that's very good. And how many of you are responsible for managing, are like the administrators of those clusters? No one. Oh, okay, 2, 3, that's good. Last one, I promise, is how many of you are involved into platform or governance decisions around those Kubernetes clusters in your business? All right, a few hands, very good. Nice. I see so as well. That's also good. Very well. So first, I'm going to go briefly through the cloud platform we have at ABN AMRO, the way of working on premises, just the part that is important for our decision making when we're designing how to provide AKS for our internal developers. Then I'll go into the 2 implementations we did for AKS, how did we provide this for our internal DevOps teams, and how they can consume those services. Now, for the cloud platform way of working, very simple. All developers work on top of the DTAP approach. So our solution also as well must work with those environments independently. So we must be able to create those clusters on each of those environments with roughly the same configuration for them. So they can also test their own clusters and the change they do on the clusters on each of those. And the second one is the business is heavily based on the self-service approach. So most of the platform is accessible through a request fulfillment solution where they can request, for instance, the access to those environments, to create the environments on the cloud. Also, the network has a solution to manage the private address space centrally, and then they should use this. So this means for us, we don't need to manage these components of the platform. It is already provided, we just consume it to create our own clusters. As the premises, the target cloud is Azure. There's no other one, so it's very simple. We just target Azure for everything we do, so it can go even native. So it simplifies our work. Second thing is the entry point for this target cloud is mostly Azure DevOps, is the solution we decide to use for both platform and the DevOps teams. So everything goes through Azure DevOps. A few edge cases go through Azure Functions. For instance, the governance that needs a higher privilege account to manage the tenant level goes through Azure Functions. And then we have the platform teams that lay the ground on top of Azure to enable other platform teams, but also the end DevOps teams to use the cloud in a stable way, in a secure and a compliant way. So for instance, to configure the IAM on the cloud, to configure the privilege escalation using PIM, and then our team, for instance, status to enable AKS to be used across the company, and also even some teams that work on non-native solutions like Nexus Repository Manager for artifact storage. And then, with all this work done by the platform teams, we then have the DevOps teams that are true heroes here that work on the end customer solutions on top of everything we enabled so far. They also go through the same endpoints here, so they use also Azure DevOps to deliver everything on this cloud, to configure anything through Azure DevOps. Now, to the specifics of the implementations, let's go first on the secure product version of AKS that we did. There's also a few specific components of the cloud when it was on version 2. Laura already briefly touched on it. So first of all is the DevOps teams were not entitled to do the developer their own infrastructure code. So they're not supposed to use Terraform or Bicep or ARM templates or whatever else there might be out there to do their own infrastructure. Instead, they were supposed to use self-service solutions to request everything they needed from the infrastructure. And to deliver that, we created mostly custom tasks on Azure DevOps, for those that are aware of Azure DevOps design, using the VSTS extensions, coded on C# and PowerShell, depending on the case, which also provided the business the way to restrict what could be used from the cloud, so not everything is available through those tasks. And for the services that are, they are restricted in a couple of actions that people can choose. So create me a VNet with a subnet for AKS, for instance. So there's patterns for them to use. It's not completely free. And access-wise, developers do not have access to change anything on the cloud directly. So they mostly have read access to their own resources and a few shared resources. And they can freely use Portal or command line or APIs. And any changes must happen through pipelines on Azure DevOps using a service principal provided by the governance team, so provisioned during the onboarding, and granted through a service connection on Azure DevOps. Now, the implementation, considering all these restrictions and these premises, we didn't go with a custom task on Azure DevOps because that would mean we need to maintain this task. And Kubernetes is a very fast-paced project, as you all know, and then updating it to keep it up to the same pace, provide all the features, would be a bit of a nightmare. So we decided to go a bit simple and provide all those DevOps teams 3 pipelines to manage those clusters. So 3 pipeline templates, they just reference and pass a couple of parameters, and that's it. They get the job done. The first one we created, we call the pre-flight pipeline. This is mostly to validate a few of the components that are out of our control to ensure we can create the cluster on top of their environment. So they have their own DTAP environments, their own subscription, their own resource groups. They need to request security groups on Azure Active Directory, and also have the network in place. So here we validate those security groups. We validate that the customer provides us a key vault where we can store some secrets, and the network, VNet, subnet, and network security groups to ensure that the cluster will work after it is deployed. So they cannot just use any sort of VNet. There's a specific pattern on the self-service solution for the network team to make sure it will work. The second one is the prerequisites pipeline. This is run once in a blue moon. It is used to create a few resources that are used to manage the cluster, but also to deliver some components to make it simple for people to use this cluster. So here, for instance, we create storage account for Terraform to store the state. Back when this was first designed, we didn't have Terraform Enterprise yet, so storing the state on the customer subscription was the way to go. So we create a storage account here, configure it. The second one is a storage account for network file share, because the idea is to install in the cluster file share provisioner, Azure File Share Provisioner, to simplify for customers to scale their applications. Because if you use virtual machine disks, it's a bit harder to do read-write many. It's a bit more complicated. So you want to make it easy for customers. And if they need high throughput, then they need to look into a custom solution. So this is to speed up people to start using these clusters. Then we also configure a few components, like container insights for their logs and their metrics. This is for their own access on their own account as well. And also a service principal that we use for the cluster to access a central repository for images that we have pre-approved. The last piece here is the main pipeline, the driving wheel of those clusters for those DevOps teams is what we call the stats layer pipeline. And this pipeline has the options to create, update this cluster, delete it, reinstall the components, and so on. We do use here extensively conftest to validate the configuration, because again, customers provide a bunch of parameters on the pipeline. We transform this and make sure they're all valid values. And then we use Terraform to provision the cluster. And Terraform here is completely transparent for the customers. They don't touch any Terraform code. This is fully managed by our team, the modules we use to provision it. So it's completely transparent for them. They still see Terraform plan and apply in the pipeline, but they don't need to maintain this code. And then we also install a few components for convenience. So for instance, Vault Injector, because Vault is the way to manage secrets for all those clusters. And also Nginx Ingress, for instance, we pre-configure it already, so they have a fully working ingress on their own clusters on the get-go. Now, this has been used for over 2 years now. I have plenty of satisfied customers. And the aftermath of this is the good parts we can see of this design is it is literally a Kubernetes with batteries. So we don't just provide the raw AKS or a raw Kubernetes. We already pre-configure a few components, and they can already start using the cluster as soon as it is ready. So it's very nice for teams that are not used to Kubernetes to manage Kubernetes directly. It is secure and it is compliant because we have, Laura mentioned PCC is installed on the cluster. We have the pipelines with a few scans also using PCC. So we ensure those clusters are within the business requirements for security and compliance. Also, network level, we have the network security groups where we restrict the communication that this cluster can have. So even the customers don't have access to change this. Now, of course, there's the good and there's the bad part. The bad part is that it's not solid, this design. For those that know solid object orientation here. In the sense that it's not very extensible, as we have our own modules that is hidden away for the customer. If they need something that is quite custom, it becomes a bit more complicated to provide them access for this. Or if they need a new shiny feature from Kubernetes, we also need to take that into consideration and work and provide for them through some parameters on the pipeline. And this ties back to the second point, which is the maintenance. So yeah, we need to maintain Terraform, and Terraform changes versions, break. There are state changes during those migrations. We need to do some sort of migration of state. So yeah, it's a bit gruesome. And agility, usually agility goes on the good side on presentations. Here it is on the bad side because we depend on the platform we run on, and we don't have full control of all the components, mainly like the network. And if they introduce some breaking changes on the platform, then we are completely impacted here. From the customer perspective, this is not bad because it doesn't disrupt the cluster functionality, but they lose the control to manage the cluster, to roll out new components, to update the cluster, and so on. So still, the agility here plays a bit against us. And for those who know the reference of my presentation, we have also the ugly. And the ugly here is support, as usual, as expected, because even though we have plenty of documentation on how this solution works, how to use those pipelines, and what is provided, and where we draw the line between the responsibility, the teams, people don't read the manual. Users, they don't like to RTFM, read the fabulous manual, as you all know, or whatever is your interpretation of the F letter. They just don't read. They're just going to reach your team because it's a black box for them. And if something breaks, they don't read the error. They just, oh, there's a red line on my pipeline, and you're at fault, and they just come to you. So this is a bit of a challenge to manage, to people to understand where is the responsibility. Troubleshooting is also a bit of a problem because pipelines, scripts go to Terraform, transform data, go to API. It's a long chain of transformation of data, and troubleshooting this, especially when there's a problem on the customer cluster, is a bit challenging because you don't have access to their clusters. They are completely owners of their own clusters, and yeah, it can become a bit of a nightmare to just send logs between people on teams. Leak abstractions, well, literally, because we're doing an abstraction top of an abstraction and so on and so forth. And not everything is available, not everything is fully tested. So yeah, it's also a problem for us to manage those abstractions. And dependency hell, this is more on our way of working. We have a couple of repositories to manage the Terraform modules and the pipeline templates. And they're all pinned down, the versions are all pinned. And whenever we need to change like a submodule, then we need to change, well, very much all the chain of repositories and PRs and approvals. So yeah, it's also a bit of a problem. Now, Fast forward to today, the change of the platform and the shift into the secure context model, where Laura mentioned the strategy, the Microsoft Cloud Adoption Framework, and the secure context, the secure landing zones strategy. This is more for the governance side. From the technical side, we also had the shift in the mindset that the teams now need to develop their infrastructure. So back to the same image we had previously, now teams are supposed to develop their own Terraform code, their own bicep code, use ARM, and so on and so forth, and not use those click-click interfaces anymore. So no more custom tasks on Azure DevOps or ServiceNow like we use internally. They're all gone. So no more maintenance on those things. The most we're going to provide is some reference templates that they can use to kickstart, but the idea is not to have a central repository of modules where they can, we'll literally shift back to the old strategy where there's a team that they can just point the finger to and complain if something goes awry. Access-wise, it's pretty much the same. They still have only read-only access using their own credentials, and they still need to go through pipelines to do any changes on those cluster instances. So the solution we decided to go this time is we allow those teams to create a vanilla AKS cluster using the vanilla means. So yeah, again, using their own Terraform code, use the bicep, Azure CLI, API, their call. They're free to do that. And to secure the cluster, we rely heavily on Azure policies. We already used on the previous version, but it was a bit more restricted. And now it is much more used to guarantee the boundaries of this cluster. So what they can enable, the features, the extensions, or what they cannot enable on that. So most of those policies are deny policies. So if they try, it's just going to be completely denied by the Microsoft API directly. However, Kubernetes is not as simple. It's not like a storage account. It's an atomic service. It's much bigger, and it is a platform in itself. So we also need to ensure the perimeter within the cluster is also secure and is also still compliant. So to do that, we rely on 3 solutions within the cluster. Prisma Cloud Compute again for the runtime scanning of those containers and reporting on a central dashboard to make sure the containers that are being used don't have any critical CVEs on them. Calico for network isolation, and here also for us to enforce some global network policies to restrict the connectivity, and then enforce best practices for those customers to do their own network policies to open up communication between namespaces and the services. And all of this is possible through Flux. This is a feature from Microsoft, and this is how we actually were able to design this solution because we don't have the pipelines anymore here as the middleman to provide their own clusters. So we use Flux that can be enabled through Azure policies. So enable the extension, and then also deploy the configuration we maintain for Flux to then install those tools and configure them within the cluster. So here in the end, we have the best of both worlds. So the customers get to manage their own clusters directly, and we also have a way to deliver the security controls we need within the cluster and also externally through the Azure policies. So literally, this is the future, and the future is now. So deploy if not exist policies are used extensively to deploy those controls within those clusters indirectly, so completely transparent for those customers. We also going to shift into this GitOps way of working using Flux for ourselves to deploy the mandatory components, but also help those teams to shift from the old strategy that would be to have their own DevOps pipelines to deliver their applications and instead use Flux. So much easier to maintain. And Status, our team, will be able to focus much more on solution enablement now they don't have any more support or to maintain those abstraction layers to deliver the clusters. We'll be able to help those teams looking for solutions like Azure Container Instances, Container Apps, for those teams that don't really need a complete cluster, because it's an overkill for some teams, but also investigate some open source tools, so you can imagine the whole CNCF landscape here, to assess if this tool, the way it is provided from the upstream, if it is it can be installed on those clusters directly, or if it needs some sort of tinkering to cope with the security measures we have on those clusters. And then we can just provide to those teams saying, hey, so you want to scale your application by number of requests per second. That's completely fine. We already test Kada. It's easy to install. Here is a sample on how you can install it. No-brainer. And you can do for yourself. And same goes for Dapper, Falco, Istio for Service Mesh, and so on. Bottom line here, lessons learned is less is more. So now that we removed all those abstractions, it's much simpler for us to maintain, but also for the DevOps teams, because it's not a black box anymore, aside from, of course, the AKS service itself is a black box, but at least there's no more black box on top of it. Maybe steps are necessary evil, so the previous version, the version 2, even though it had its downsides, it was completely necessary because it was the way of working of the company and what was expected from the DevOps teams, so it was needed, and it worked quite well. Knowledge power, here's where ABN AMRO shines. They do provide a lot of support for people to learn, so we have an education budget for every engineer to consume on whatever they want to learn, not specifically technical stuff, but they also provide financial support for specific trainings that are related to the business. So for instance, they even pay for boot camps and even for the certifications for Azure, if people are interested, and it completely relates to the job that needs to be done here. So the business is really aware that educating the engineers is key here to get this new way of working to actually be successful. Platform on top of platform is hard. Well, Kubernetes is a whole universe in itself. It's for anyone that tries to go through GitHub, Gist, that is Kubernetes the hard way, knows the pain to actually get Kubernetes to run on your own lab. And even if it is abstracted by the cloud provider, it is still hard to provide it and to secure it. There's a lot of corner cases. So yeah, that's natural, and we need to be aware of it. So the less time we spend with maintenance, with abstractions, the more we can actually dive deeper into the platform itself and try to cover all corner cases for the business. Last one, security compliance isn't hard. Defining a risk is. This is much more experience when interfacing with CISO, with the team we have for security, and also security champions. Sometimes people have a misconception of how a technology works. So for instance, how a container works and how it differs from a VM. And sometimes people define something as a high risk when it's not, because of this kind of misconception, this attempt to compare things when they should not be compared. And I think here's most of the challenges we had so far was to have an open discussion with everyone involved, and then try to understand, reach a common ground of how the cluster works, what are the technologies involved, how those technologies work, and whether it is really a risk or if it is not. Otherwise, we just literally block everything on Kubernetes and it would be simply unusable. And that's pretty much it, the two implementations we had. And I think we have some time for questions.
You mentioned that you guys are working towards a new security context.
Yes?
Is that going to be implemented across the back for all the DevOps teams, or are there specific requirements that a DevOps team needs to meet to work on that secure context?
In the end, everyone's going to migrate to the secure context. Secure context put it very simple, is just a new way to organize the subscriptions and the resource groups on Azure and the access roles on top of it. So today, customers that are on the version 2 of the cloud, they are on shared subscriptions that are by area, and then they have a resource group per team. And the new model, they're going to have a subscription per team. And the resource groups, they then can have multiple resource groups within it. So this is mostly this reorganization on the management level within Azure. There's also some changes on the roles for it. But from a technical perspective, there's little change aside from the way of working that now people need to develop their infrastructure, so they cannot rely on pre-baked solutions anymore.
Okay, yeah, because I thought the difference was that they would get the freedom now to actually make use of CLI, PowerShell, and Portal.
Yeah. They will still get this. The first version of the version 3 of the cloud, they also had like owner access to the subscription. But then sooner after we started the pilots, this was removed because then, well, as you know, customers will just click through the portal and create things without any code, and that's not what we want, to people to create things manually. So yeah, we removed that. So they can still use Portal or Azure CLI or whatever tools necessary to inspect stuff. But modifying requires a specific account only available on Azure DevOps. Even for ourselves. We also don't have, we are platforms where we also go by the same rule. No worries. Anyone else? Oh.
How do you ensure teams have the right knowledge and skills to do all the things that they are not doing right now?
Oh my gosh, that's $1 million question. Well, from our perspective, as one of the platform teams, we provide as much documentation as we can. For their older version, we had like an even getting started guide on how to start using what are the prerequisites, where to go to find information, where you create your own network, and so on. For this new version, we're still going to have some sort of documentation to help bootstrap them, very much like we saw in the previous presentation. So they're going to have some sort of guide where to start, where to look for dependencies. But this falls within the team right now. So this is a mentality change, and all managers must know that the team must be knowledgeable when the things they're using. So if your team does not have knowledge on Kubernetes, you should not be using Kubernetes at all. That should be granted. It's not sometimes. But that's the way we look at it. If you don't have the knowledge, you should look for it. The bank supports you to do some trainings. But if you're not willing, then just don't use it. Go for something simpler.
And also, one of the benefits of stepping to the secure context is that we make use more of the vanilla product. So it's also easier for teams, right, to find it on the internet instead of the black box that we created before.
Which simplifies for everyone, exactly. So they don't need to look into our own specific parameter named after some crazy term. They can just use the upstream material. So Stack Overflow all the way. And well, if that doesn't solve, then the problem probably is between the chair and the keyboard. Any more questions?
Yeah, I got one. How do you regulate costs? Because if you give a DevOps team the freedom, all the slides go to the right, and then Microsoft makes a lot of money.
That's true. That's true, yeah, exactly. We need to strike the balance, right? So for cost-wise, all those resources, when they are created, they are tagged automatically through Azure policies. And through those tags, then we can have visibility about those resources. So if the team starts to create something that they don't add the proper metadata to those resources, they are outright blocked. That's pretty much it. So they must add this information. So they must add the area, the specific team code. There's an internal identifier, and even there's an identifier per solution within the bank. So all solutions must have a solution intent documentation, and they are granted a specific unique ID for this solution, and this must be everywhere. On all resources they use, repositories, anything that is related is an artifact, must have this. Same for the containers, like Laura mentioned, the container governance team. It also receives this metadata information. So we can trace this back and then summarize this. We have now Power BI to calculate the costs per team, per area, per specific type of application on Azure. And that's how we are using. So if someone tries to just be smart and just remove the metadata, they're just going to be blocked, and that's it. They're not going to land on the platform.
Yeah, based upon the data, we also can give recommendations if we see the usage on best practices.
this is next step. With the data we have on Power BI, now we can drill down and then come to the team and say, hey, your cluster is like using big nodes with 64 CPUs and using just half of it. So better do some proper capacity planning and reduce your cluster, because that's a huge cost. So yeah, that's the next step. Oh.
You addressed the topic knowledge. Is that sufficient for a team, or do they also need skills and experience?
It's never sufficient, right? People always try to bite more than they can chew. So we try to ease that learning curve, providing our own sort of documentation and point to upstream material, so do some sort of curation. But no, this is never enough. So we still need some sort of support interface to help teams to understand how to use AKS now, all the options they have, but it's it's hard to solve. I would wish to solve this with some software logic and automate knowledge streaming, but we're not there yet. Yeah.
Moving to the secure context, are we reducing certain reusability components? Because earlier, like from the standard team, we were getting those Terraform implementation, and now every team is gonna build it. So that's also you see happening, or?
Sure. Yeah, this is literally one thing we're still looking how to best approach. There is a team that is responsible actually to provide some reference templates, as we call, in Bicep right now, for teams to start using, especially for the pilot ones, to start using the new strategy. But there is also, we're trying to strike a balance, because if we do provide a center repository with Terraform modules and Bicep modules, the problem is that we're going to actually shift back into the old strategy that people just deploy infrastructure. They don't develop their infrastructure. And if something goes wrong with the module, they're just going to point fingers to the platform team that is responsible for the templates. So this is still, we're trying to figure out how to best do this. One idea is to have an inner sourced repository where everyone can contribute with modules for any infrastructure as a code solution. But then it must be crystal clear to them that this is not something that is like supported. They should take with a grain of salt those reference templates. Even if they import and it starts breaking, then well, it's their job to make it work. Any more questions? Should?
For the OS base images, like, is it directly taken from the repository, or do you also guys do some hardening or some policy implementation on those OS base images as well?
Good question. So what we do is it's mostly the vanilla image from the upstream, because we don't want to introduce any breaking changes on those images from the upstream, so it should be mostly the same. The only change we do for some images is to configure proxies. We use Nexus Repository Manager, and we proxy pretty much all package managers you can think of, so Debian packages, Alpine, Python, and so on. And then we pre-configure within the image the Nexus to be used as the upstream for retrieving those packages. Besides that, we add metadata, again, for the compliance part, and that's it. We call it a day. The idea for restricting security images for teams is that we're going to vet some labels from the upstream, so the teams will not be able to use all versions from the upstream. We're going to restrict. So for instance, Alpine 2, it's super old, so that's a version that they should not be using. So that's not going to be available on Nexus. It's going to be completely removed. And this is going to happen in the future as well. When Alpine goes to version 4, we're going to probably deprecate version 3 and say it's not usable anymore. They should migrate. So this is how we're going to control. We're going to restrict by the label, by the tag of the images, and just do minimal configuration on the image so it is operational. So they don't need to tinker with HTTP proxy, pass arguments to the Docker images, and make all those kind of mess stuff. They just focus on creating the container with their solution itself.
And would there also be some proxies for the packages of that OS itself as well, or would they be just down, like for the Red Hat, if I need something with yum install on top of that base image, would it be downloading from the internet or within the proxy of ABN AMRO or something
from the proxy, from Nexus. All packages, all resources must go through the Nexus. It's the golden source for the business, and everything goes through there. And from Nexus to the upstream, there's direct connectivity, of course. It just acts like a pass-through proxy for some of those resources. But then you can also secure it to ensure, for instance, the connectivity between Nexus and the upstream it is secure, so pins, certificate fingerprints, and so on. But at the end of the day, for most of those packages, it's just a pass-through proxy. Any more questions? Nope. All right, well, that was everything. Thank you.